integration today. So let's focus and let's ready for this part. And that is again we are dealing with basic maths which are required in physics. Okay, clear. So let's move towards integration. What is basically integration? So integration is summation of continuous things. Continuous thing. Continuous things. Okay, summation of continuous things basically is called integration. Okay, let's say that if I am saying that we have a rod like this and we have a particle like this. A particle means no dimension, it is basically a point. Let's say this is of 1 kg and this rod is of 10 kg, let's say, and of length 5 meter, and I want to find out the interaction force, the gravitational force between one another. What is the gravitational force acting on 1 kg and 10 kg due to one another? Okay, you have to calculate it. So what you will understand that you have the basic idea that gravitational force can be calculated as capital G m1 m2 upon r square, where m1 m2 are point masses, means the masses must not have any dimension. R square is the distance between point masses. Clear? The square of the distance between the point masses. But here in the case you can see that one is point mass but another one is not a point mass, since it is having a dimension of 5 meter. A point mass will not have any dimension, right? So how will you do so? How will you do here? What will you do to get the gravitational force between them? One thing is very much clear to you, that there must be gravitational force between them. Okay, there must be gravitational force between them. That's why whenever you toss a coin, it finally fall onto the surface of the earth. Reason? Force between the force between the earth and the coin is acting there, and the gravitation, due to gravitational force, the coin falls back to the earth. Okay, so let's try to understand how will you do so. So Newton, thanks to Newton introduces the concept of integration, where he says that when you divide this particular body into so many elements in such a way that each element is very small in length, very small in length. Let's say it is of dx length. Here dx is very small, infinitesimally small. And let's say that this particular dx element is at a distance of x from here. So then you can confirmly say that between 1 kg mass and this dx mass, this particular element, whatever be the mass of it, let's say its mass is dm, there must be some gravitational force. Since dx is very small, you can assume it like a point mass. So you can say between 1 kg and dm, gravitational force is basically g into 1 into dm, and the distance between them is x. We are ignoring dx since it is very small. You can write down x plus d, it will remain as x. Okay, so it is a gravitational force between 1 kg mass and dx. Now imagine, since this x is variable, this x starts from here, and finish to this particular thing, the end of this rod, and so from this to this there are many value of x possible, infinite value of x is possible. So when you try to figure out each g into 1 into dm upon something x square, and you have to add every element, every forces, to get the total forces acting on the rod, which is not possible with help of simple summation, since simple summation do not have any way to calculate, do not have any approach, do not have any method to calculate addition of infinite number of elements. So here what you have to do, since the number of elements, since x, you can say that let's say this is 1 meter, so x can be start from 1 meter to 6 meter. X can have the range from 1 meter to 6 meter, and between 1 meter and 6 meter there are infinite number of points possible. So how will you do addition? There is no way to add it simply with the help of addition you have learned in the primary classes. Here the method works, which is called integration, the integration sign is same as that of summation. This is s. Okay, this is s, and you have to, let's say this force is very small, since this force is small because I want to say that the force is between 1 kg and this one. Okay, I'm comparing the small f as compared to the whole f which is acting on it. Okay, there are infinite number of elements. Okay, and this is one of them, this is one of them. So amongst the infinite, this is one of them, so I will say this is very, very small as compared to that. Okay, so this df has to be integrated. Such type of df will be infinitely number, and you have to add it everyone, each and every one, and get the answer. This can only be possible by the method called integration, whose notation is like s. This is notation, this is notation of integration. Integration. And here you will come to know that how will you integrate it, but when I'll tell you what are the methods involved in doing the integration. This example has been taken just to give you a brief idea that why is the need of integration, from where this idea of integration comes. So the idea is coming from where, basically when we have to do summation of continuous things. Here you can see that from 1 to 6 meter, there are infinite number of numbers and all are continuous. There is no gap between them, like 1, 1.000001, then 1.000011, and so on. There is no discontinuity involved here, and you have to sum them. So these are the infinite number of elements which you have to sum, and this cannot be done by simpler way. It can only be done by another approach which Newton have given us, and that is integration. So let's try to understand the rules of doing integration. Okay, so the rules of integration. Okay, let me tell you, integration is also called antiderivative. This is also called antiderivative. This particular name will be helpful in remembering the formula of integration, and you keep in mind that you have to remember the formula. Without remembering it, there is nothing benefit of learning integration. Okay, so let's try to understand that whenever you have been asked to do integration of, let's say, any element, let's say we have x raised to 2, and you have to integrate it with respect to x. This is basically, how will you read this? Integration of x square with respect to x. Okay, how will you read this? Integration of x square with respect to x. So what will you do? That you have to integrate x square with respect to x. So you can think like this, that integration is also known as antiderivative. So you have to think about an answer. On the differentiation of the answer, question must come. Okay, like I'm saying that if I'm saying, let's talk about x cube by 3, differentiate it will as 3x square by 3 can cancel out, and x square is coming, which is the question, right? So the answer of x square dx is x cube by 3, and you can have the intuition, you can have the thinking that you may think that what should be the value, what should be the data on the differentiation of it. Question must come back, isn't it? This is how you can remember the formula of integration. Okay, so before giving you the formula list, let's talk something more about it. Integration is of two types. One is indefinite, and another is definite integration. So during physics numericals, you will come to the situations in which you may be unaware of the limit, that what is the range in which you have to integrate. Like in this question, we have to integrate from 1 to 6 meter, Sometimes you may not be aware of this situation. So such type of integration will be called indefinite, since you do not know from where to where you have to integrate it. Indefinite, simply unknown limits. Okay, no limits are known, unknown limits. Unknown limits. What about definite integration? When you know the limits from where to where you have to integrate, this is called definite integration. Known limits. Cool. Now you may say that when what is the way to write an indefinite integration? When I'm writing indefinite integration, I'll say it is f dash x dx is basically fx plus c. Now this is in this here you can see that I have introduced a constant c, whose value is unknown. This constant, but unknown constant. Okay, unknown. Why I'm writing, since I don't know the limit, so I can't confirmly say about the answer. Since limit integration is also called antiderivative, when you differentiate this whole thing, question must come, and you know the differentiation of constant is 0, so this constant can be 0 and can be anything else. So when you differentiate it becomes 0, and when you differentiate it, it becomes f dash x. So I'm writing in a very well manner that this is the way to write down indefinite integration. This is the answer. You can see this is differentiation of x. If this dash represent differentiation of function with respect to x. What I'm saying, this f dash represent what? Differentiation of fx with respect to x. What does f double dash x represent? Double differentiation. We have to differentiate two times, one then another, and then again double differentiation of fx with respect to x. Cool. Like this, if y is fx, f dash x means dy by dx, and f double dash x means dy by dx differentiation. It means I have to differentiate dy by dx again with respect to x, so it is d2y by dx square. Okay, cool. Now what about definite integration way to write it? Simply it is f dash x dx. Okay, now put a to b. Now these are the limit. This is called lower limit. From where to where? Lower limit. And this is upper limit, and you have to integrate it. The answer will come in a definite way. You will know about the value, not in the term of variable, a proper value, no unknown term. Okay, so let's talk about the formula list and we will come to know. Okay, so the formula, keep in mind there is less number of formulas compared to differentiation. If you have to integrate ax plus b, where a and b are constant raised to n, with respect to x, answer will be ax plus b raised to n plus 1 upon n plus 1 plus c, since I am not putting the limit. Okay, if I will put the limit, I'll remove the c. Okay, so moving ahead, where a and b are constant, and n is not equals to 0. Cool. Now, and also n is not equals to minus 1 as well. Okay, number 2, 1 by ax plus b. You can see that this n equals to minus 1 comes in the next formula. Integration is remember, this integration will also have division with b, as division with a, whatever be the coefficient of x, here you will have to multiply 1 by a. Okay, ln ax plus b into 1 by a plus c, no problem. Next, integration e raised to ax plus b dx. Answer will be e raised to ax plus b into 1 by a. Next is sine ax plus b dx. Integration will be minus cos ax plus b 1 by a. Okay, next is cos ax plus b dx. Answer is 1 by a sine ax plus b. Next is, now you can have the intuition, you can have the way, you may have catched the way I'm writing the formula, right? And let's say we have a constant c fx integration dx, put constant out of the box, fx integration only. Okay, fine. and anything else if you solve the covered, right? Only these things. Okay, great. So these are the formula list. Now how will you do integration? Let's say I'm giving you, and a rule, another rule is rule only addition and subtraction rule. Addition subtraction rule. If y is u plus v, u function of x, v function of x, you have been told integrate y with respect to x, y with respect to x. You can distribute this integration, do integration of u with respect to x, v with respect to x, and put the sign whatever it is as it is. If it is minus, then put minus here. Great. No division and subtraction rule here, no division and multiplication rule here. There are the rules, but you may come to know about all of them in the mathematical section. Okay, not here, not needed in physical part. Okay, great. And now let's do some question. Let's answer saying that we have sin x dx integration. Your answer will be what? You can see this is minus cos x. Here a is 1, b is 0. Put in the formula, I will get the answer. And since limit is not discussed, you have to put a constant, unknown constant also. This is the case of indefinite integration. Answer, you can see it is in the term of x, and c is still unknown. This is indefinite integration. What about when I put the limit here? Let's say sin x dx, and let's say x is 0 degree to x is 30 degree. So do the integration as it is with the help of formula, whatever you've written the formula as it is. Okay, and all the formula you can put c if you are doing indefinite integration. Since I have used c already here, so I am putting c dash unknown constant. Okay, great. So moving ahead, when you were looking that limits has been described from 0 to 30 degree, use the formula list to write down the formula for sin x, which is minus cos x. Now after that don't put c here, don't put any unknown here. After that, put the limits x from x0 to 30 degree, x0 to 30 degree. Now this is upper limit, this is lower limit. First put upper limit instead of x. First put upper limit instead of x. The cos in place of x, you will have to put 30 degree. Okay, keep in mind, very careful about the calculation, right? Then put a minus sign here, put a minus sign here. Thereafter again put the lower limit instead of x, what it is, minus cos x is 0 degree. Now calculate it, put the values. Minus cos 30 is minus root 3 by 2, this minus get plus, cos 0 is 1. So answer is this. There is no unknown term here. You can see this is how you have to do definite integration. I hope you understand about these things and it's very much clear to you. Okay, and this is enough to solve the question in physics. Okay, sometimes you maybe have some integration based on substitution. Let's see some of them. Integration by substitution. Let's say that I am saying it is sin x cos x, or you may say that we have, let's say, t square let's say t upon t square plus 1 dt. This is the integration you have to do. 0 to 1. How will it do? You will see that there is no formula working here, but you can see that if you put t square plus 1 as let's say m, differentiate both sides, or you can say you are differentiating with respect to t, then t square differentiation with respect to t become 2t. 1 is a constant, so differentiation becomes 0. M with respect to t is dm by dt. Okay, you understand? Now 2t dt is dm. Now you can say t dt is dm by 2. Now put here it is t, here it is dt. Now in place of t dt you have to put dm by 2. upon t square. Now what you have to substitute in place of t square plus 1? As m. Cool. Now you can see it is 1 by 2 dm by m. 1 by 2's constant will be out of the box. Dm by m it is similar to dx by x. In dx by x you have the formula in the formula list. It will be ln x. Okay, ln x, not basically here we have used in place of x as m. It is ln m. What is m? M is t square plus 1. Put it, resubstitute it. What it is? T is equals to 0 to t is equals to 1 in the limit part. Now resubstitute m as t. What it is? M is t square plus 1. It is 1 by 2 ln m is t square plus 1. Cool. Now it is t square plus 1 t 0 to 1. Put limit, instead of t put 1. It becomes 1 by 2 ln 2. Now instead of t put 0. It becomes ln 1. ln 2 minus ln 1. ln 1 is 0. So answer is ln 1 by 2 ln 2. This is the answer. You can say ln root 2. This is the answer, right? Fine. So this is how you can do substitution anywhere. Substitution is not very much needed in the physics part, but it may be used sometimes. So you must understand that this is how substitution works. Thank you. This is right.